If you're too scared, I forgot my packet at home.
Okay, you want to email it to me?
Want to get home? Yeah. Do you want me just to take pictures? And okay.
But are we gonna go through them today? Sheen came. You doing any games for? Why? This suck. It doesn't matter. We just got that. Why should Southside be the Rebels? What? You said they should be the
Mr. Townsend, I'm missing next Wednesday.
Just missed last class.
I know. I'm missing next Wednesday and the following Monday. Do you have papers that I can grab yet, or should I wait till next
You're
Monday?
missing this Wednesday?
No, next. But I just wanted to let you know ahead of time.
Yeah, but ask me again on Friday.
Okay, cool.
Then I can give you a little better
Okay, sounds good.
estimate. Everett, James back, David, Patrick, Owen. There you are. Jessica. And then Julio.
I should have
Catch
gone
Chrissy
along
today.
and
What? I know you get to Chris. So you get.
Have you had them before? A lot of success, I imagine.
Yeah.
Oh, yeah.
Mr. Townsend, why do you have 3 underpatches over there?
Those are to scare y'all off your phones.
I knew that was like a
I got a whole pack of 30 of them.
You what?
I've got a whole pack of 30.
Oh, you just have 3 out to scare us?
Yeah. Well, I don't need 30. Look, I got a whole pack.
Oh my god.
Okay, good morning, guys. I do need your assignment from last class, which was 55. And then the thing that we did together on your own piece of paper, 56, I'm going to ask you to add to that today. So if you would please dig that out of your binder also. All right, we got 2, 4, 6 people out sick, and Andrea.
Everybody's getting sick. So.
Yeah, me included. I'm also getting sick here, so you might want to try to stay a couple arm lengths away from me.
Mr. Townsend, when was the last time you missed school?
Last time I missed school? Well, I took a personal day. About 7 years ago. But it was like, I don't know, 4 or 5 years before that when I was sick and took a day.
Did you actually work only on Wednesday?
Huh?
I heard people say that you worked only on Wednesday.
Yeah.
What? Yes.
I came to school and I did my classes on a Friday and then I went home and got married.
Wow. That's some serious commitment.
What would I have done if I had not come to school and then got married? What's the
You should
difference?
get a raise.
I should get a raise, thank you.
Is your wife mad at you?
No, I told her that she needed to go to work too. She was going to go to work and then she, like last minute, she decided to take the day off, so.
Go.
Okay, let's go ahead and start here. So we are moving on to something called alternating series. So I'm going to talk to you about that, talk to you about how to do those. I think this is on the easier side of some of them that we have to do. The blank piece of paper last time that we wrote down the 5 tests, just kind of as a visual where everything was, what a geometric looks like, how you know if it converges or diverges, what does it converge to. But then same thing for harmonic series, same for integral tests, same for p-series tests, same for nth term tests. Because again, what I told you is none of these tests individually are that bad, but they do build up. So after we talk about the alternating series tests and go over their examples here, I'm going to ask that you update the 2 tests from last class. That was the comparison test and the limit comparison test. I'm going to ask that you add that to your blank piece of paper 56. Of course, you might want me to pass that back first, so let me grade those and get them back to you. And then otherwise, then I want you to go back and finish up our work on alternating series. So, this is a new one for you. Okay, so first off, you need to know what an alternating series is. So what it means by alternating is that it's either starts as positive, then the next one's negative, then the next one's positive, then the next one's negative, etc. Or you could start with negative and the signs alternate. So second term has the opposite sign as the first term, the third term has a different sign than the second term. That's what an alternating series is. Now, most of the time, you're going to know something's an alternating series, and like any of our other tests, you need to know it's an alternating series before you do this. Just like if something's not a p-series test and you try to apply the p-series, or if something's not a p-series and you try to apply the p-series test, it's just, you might get an answer, but it's only going to be right if you're lucky. So something like this is what makes it alternating. Because when n is 1, this guy is negative. But when n is 2, it alternates to being positive, because anything squared is positive. Then when n is 3, it goes back to being negative. When n is 4, it goes back to being positive. Same idea over here, except this one starts off at n is 1, so this one would be positive, and then the second one would be negative, the third one would be positive. It alternates. So those highlighted things are what you need to note about alternating series. Now, there's only 2 things you have to check. If it's an alternating series, which is a big if, but if it's an alternating series, you need to make sure the limit as n approaches infinity of a sub n, this is a sub n, not the alternating part of the series, the rest of it. What do you think this needs to be equal to if we want this to converge? We need it to be 0. That's basically the nth term test. It's saying if the nth term test doesn't work, then it diverges. But that's one requirement for an alternating series to converge. And then the next one is, it looks a little funny at first, but the absolute value of a sub n plus 1 has to be less than or equal to the absolute value of a sub n for all values of n. So this is a mathematical way. To me, when I read this, if I pick a term, the absolute value of it needs to be less than or equal to the term before it, because a sub n plus 1 is the term after a sub n. So worst case, this is also kind of like decreasing. It's not exactly decreasing because it could be negative and increasing. It's more like it's approaching 0. If you take a term and it is smaller than or equal than, or if it's closer to 0, that's a way to say the absolute value, than the previous term. If that happens the whole way through, then that is enough. And if both of these things are true, then it converges. Okay, so worst case, if you're not sure about this, you could try taking the derivative, and when the first derivative is negative is when it's decreasing. A lot of times it's just going to be obvious, and you'll see what I mean by that. Or down here, you could manipulate this. So you could actually do, you could subtract this a sub n plus 1 over. So if you take a term and subtract the next term, if that always is greater than or equal to 0, that's the equivalent to this. But the one that I like, and so the one I'm going to lean on, of course, all of these are the same, so you can pick what you like. But if you take a term and divide it by its previous term, if that's true for all n, it'll be less than or equal to 1. This is the one I like to use. This is the one that makes more sense to me on the harder questions. Okay, so we've got 5 examples here. So, question 1. This is an alternating series because of this -1 to the n. What I am going to call a sub n is the 1 over n. Now, if this -1 to the n was not there, does 1 over n converge or diverge?
Diverge.
Because it's the what series? Harmonic series. Now, just because it's the harmonic series, or it's a version of the harmonic series that diverges, doesn't mean this diverges. So what we would want to test is, does the limit as n approaches infinity of a sub n, so not the alternating part, just the a sub n part, so that is 1 over n. That's supposed to equal 0. Does that one equal 0? Okay, then we're halfway to saying it converges. And 2, I need to make sure that any term I take divided by its previous term will always be less than or equal to 1. So what I would recommend doing here is just write out the first few terms. If you plug in 1 for n, you get -1. If you plug 2 in for n, you get a half. If you plug in 3 for n, you get minus a third, then plus a fourth, minus, etc. And that goes on forever. So any term I take, if I take this divided by this, 1/4 divided by a third, is that less than or equal to 1? Okay, is a third divided by a half less than or equal to 1? Is a half divided by 1 less than or equal to 1? Okay, so then it seems like that is working as well. And if both of those tests work, and assuming it's an alternating series, that's all you have to check. If either one of those mess up, it diverges. If both of those work, it converges. Now, for this one, again, I think it makes sense to just write out the first few terms, and then you can kind of analyze. You can take any term divided by his previous term. You know, if you're not sure if 1/4 divided by a third is less than 1, of course you can, you know, do that over here to the side and see that it's less than 1, but it's got to be for all n. So if it just works sometimes, that's not good enough. But on question 2, that's not going to be so convenient. We've got an alternating series. The first thing I need to test, does the limit as n approaches infinity of a sub n equal 0? So all of this is a sub n. So is that limit equal to 0?
Yes.
Okay, think of your horizontal asymptote rules. You don't actually have to FOIL this out, but the degree of the denominator is 2, the degree of the numerator is 1. So we're halfway done to our answer. And then part 2. If I take a term and divide it by its previous term, is that always less than or equal to 1? That's a lot harder to see on this question, right? Because there's so much going on. So what you can do is you can take a sub n plus 1, which would be taking a sub n, but everywhere there's an n, you replace it with the n plus 1. So this would be n plus 1 plus 5 over n plus 1 plus 2 times n plus 1 plus 3. Okay, so this guy right here is everywhere there's an n, I put in an n plus 1. I'm going to divide it by a sub n, which is given to me. And how do we normally divide fractions? Okay, multiply by the reciprocal, so you can make an extra step out of that, but I'm going to just erase and redo it. Okay, so here's my a sub n plus 1 divided by my a sub n, and this is going to help me figure out if this is always less than or equal to 1 to know if it converges or diverges. Now, this is the hardest one of our examples, but notice n plus 3 would cancel out at n plus 3. After that, there's not much that you can do. But your numerator, we could FOIL this mess together. And the denominator, we could FOIL this mess together. Now, I think that's probably good enough to realize that that's always less than or equal to 1. But if you still don't see that, here's one last trick that you could do. Instead of calling 9n 9n, what if I call them 8n plus 1n? And instead of calling this plus 20, maybe I'll call it plus what plus what? Plus what? Very good. Plus 12 plus 8. How did he know plus 12? Right, so you can basically imagine this stuff is going to cancel out this stuff, and that's essentially 1, but your denominator still has stuff. So this is certainly less than or equal to 1 because the denominator is bigger than the numerator always. I can see that back here, so I don't really need to do that. But so if that's true and that's true, he converges. If it's an alternating series and either one of those is not true, it diverges. So again, this is the reason why I like to think of this one in purple. Because if you think of dividing these and seeing if it's less than or equal to 1, take this, divide it by this, or multiply by its reciprocal, and then you can try to simplify a little bit, and then it's a little easier to see if it's less than or equal to 1. Okay, question 3. Okay, is question 3 an alternating series? Okay, what makes it an alternating series? Okay, so the rest of this stuff is a sub n. Okay, what's the first thing we should check? Just because it's quicker. Okay, do the limit as n approaches infinity. And what is the limit in this question? Okay, degrees are equal, so leading coefficient over leading coefficient, horizontal asymptote rules. So what does that mean? It diverges. It messed up the first part of the test, so you can quit as soon as you figure out either one of those parts doesn't work. This is just the quicker of the two. Okay, what about question 4? Is this an alternating series? I'm seeing some no's. Here's where you have to be careful. If I start writing this out, if I plug 1 in for n, I'm going to get the cosine of pi, which is what? Okay, over n. So 1 over 1 is negative 1. Okay, then I plug in 2 for n. What's the cosine of 2 pi? 1 times 1 over 2. What's the cosine of 3 pi? Okay, negative 1, and if n is 3, it would be negative 1/3. So that negative 1 to the n is how you usually see that it's an alternating series. But technically with trig functions, sine and cosine, since they oscillate, those can also make alternating series. This is an alternating series. Every term alternates between being positive and negative. So this is your a sub n. Make sure the limit as n approaches infinity of your a sub n is 0. It is. And then 2, make sure that, well, we've already really wrote this out on the first one, question 1. But you could also try the dividing thing. I could take n plus 1 divided by a sub n, which is the same thing as a sub n plus 1 times the reciprocal of a sub n. And if I write these out like this, is this always less than or equal to 1? How do we know that's less than 1?
Denominator's always bigger.
Right. If your denominator is bigger than your numerator, then your fraction's less than 1. So that works. 2 things work. Then it converges. So you have to be careful. It's usually, alternating series are usually this -1 to the n or -1 to the n plus 1, something like that. But it could be a trig function. So last one, before I remind you what I need from you today, and then let you get to it. Question 5 says this is not an alternating series, but it has this. So why is that not an alternating series then? Okay, well, that's not necessarily a bad thing. Okay, so let's plug in a couple of these. If n is 1, I get -1 times the cosine of pi times n over n squared plus 1. So that would be +1/2. So to be an alternating series, what has to be true about n equals 2?
Negative.
All right, it needs to be negative, but if I plug in a 2, this becomes a +1. Anything to an even exponent is positive. That will come up in one of your questions here in a bit. Times the cosine of 2 pi, which is +1, times n, which is 2, over n squared plus 1. And we get +2/5. These are always positive. That is why it's not an alternating series. So if just a -1 to the n was there, it would be alternating. If just the cosine of n pi was there, it would be alternating. But they're both negative or both positive at the same time. So if they're both negative, a negative times a negative makes it positive, and if they're both negative or both positive, a positive times a positive is positive. So that they cancel out the alternating part. So just because it's there doesn't 100% means it alternates. Sometimes you want to write out the first couple terms to give yourself an idea of what's going on. Okay, so this was a very easy assignment to complete today, or at least it was from my first period. So if you would, go ahead and start on the practice questions here. And give me just a minute or two to get these homeworks put in, and then I'll remind you the one other thing you need to do for me today. Email me.
Do that first, please.
Now that I got your homework back to you, again, I need two things from you. I need you to practice and check your answers to today's alternating series stuff. The solutions are on the website for you to check. Again, there's a couple trickier ones, but overall, I think it's one of the easier ones we have to do. But I would also like you to update 56 that I asked you to get out. So, using your homework, I'd like you to add to that blank piece of paper the comparison test and the limit comparison test. How are you supposed to know to use it? When does it tell you when it converges or diverges? I'm not going to tell you how to write that down like I did last time, but I would like you to at least add that. I will also be asking you to add today's alternating series to that page, but you can wait and do that next class or after you finish the practice. Once you kind of get the hang of it, I'd like you to write it down after you get the hang of it so that it's a little more efficient and you're not just copying down what it would say in the textbook. So again, I do have the answers posted. Please let me know which questions I can help you with. Again, as always, you guys are welcome to bring it up here to me, but since I'm starting to feel sick, I would get that you probably want to avoid that. So I'd be happy to work any of the questions you need help with on the board. You just need to holler and say something. Otherwise, I'm going to try to keep some distance so that you don't get my sickness. So.